integration by parts. Now, from the product rule of differentiation, we know that we are considering y is equals to uv, where u and v are functions of x. Now, differentiating that, we have the d dx of uv is equals to v du dx plus u dv dx. Now, let us now rearrange these terms. So we are arranging it with u dv dx coming up. We give us d dx of uv minus v du dx. Now we can now integrate both sides with respect to x. Therefore, we are integrating this with respect to x, integrating this with respect to x, and integrating this with respect to x. And then we'll be left with integral of u dv is equal to uv minus integral of v du. This formula is known as the integration by parts formula, and it provides a method of us integrating terms as integral of x exponential x dx, integral of t sine t dt, and the likes, and using integral of x in x dx. Now the question remains, how do we know which one is u and how do we know which one is v or dv? Now there's a simple rule to determine u and to determine dv. It is known as LAET, where L is logarithm functions, R is arithmetic function, E is exponential function, and T is trigonometric functions. Now logarithm functions can be ln x, arithmetic function can be x squared, x raised to power 3, exponential function can be x raised to power exponential x, trigonometric functions can be sine x, can be cos x, and can also be tan x. Now we are moving from L to A to E to trigonometry, from logarithm to arithmetic to exponential to trigonometry, and we are moving in this format. So let's take, for instance, we have integral of x exponential x dx. Now we know that x is arithmetic, exponential x is exponential. And now if we come to LAET, the first on the line in this order will be our u. So moving forward, we know that we are going to meet A first. So this will be our u. And this will be our dv. Let's try another example. Let's take integral of x cos x dx. X is arithmetic and cos x is trigonometric. Now let's look at LAET again, LAET. In this order, between A and T, we are going to encounter A first before we meet T. Therefore, our x is taken as our u and our cos x is taken as our dv. Let's try to explain further again using integral of, let's say, 2x ln x. Now in this case, we have arithmetic and also we have logarithm. So moving in this format from logarithm to arithmetic to exponential to trig compared to a and l, what we will encounter first is our l. So this ln x will be taken as u and a, and the arithmetic, that is the 2x, will be taken as the v. So let's take examples on this to establish understanding on integration by parts. So the first example we will take is the integral of x cos x dx. Now recall that the integration by parts formula is u dv is equals to uv minus integral of v du. And considering LA ET, our x here is arithmetic and the cosine x is trigonometric. So moving in a progressive format, we are going to meet arithmetic first, which will be our u, and trigonometric later, which will be our v. So let us compare u dv to x cos x dx. Now we can say that u is equals to x and the v is equals to cos x dx. So u is equals to x and the v is equals to cos x dx. And from our formula, we are going to be needing du and we are going to be needing v. So let us evaluate du dx. Du dx, when u is equals to x, is equals to 1. Therefore, du is equal to dx. Now to evaluate our v, we will integrate both sides, and this will be v is equals to integral of cos x dx. And integrating cos x, we will be having sine x plus c. Therefore, if u is equals to x, we know that our du is equals to dx, and if our dv is equals to cos x dx, then our v is equals to sine x plus c, or we can just simply say sine x. So let's go again to our formula of integration by parts, which says u dv is equals to uv minus integral of v du. Now our u is x and our dv is cos x dx. Our u is x, our v is sine x minus integral our v, which is sine x, and our du, which is dx. Therefore, with this done, we can go ahead and find an expression for integral of x cos x dx, and this will give us x sine x minus integrating sine x now will give us minus cos x plus c, and this will give us x sine x plus cos x plus c. Therefore, integral of x cos x with respect to x is equals to x sine x plus cos x plus c. Let's take another example. We are asked to integrate with respect to t, or let's integrate with respect to x of 5x exponential 4x dx. Now 5x is arithmetic, exponential 4x is exponential function. And considering LAET are moving in the progressive manner, we will realize that A comes first. That means it will be our U, and exponential will be our dv. Therefore, we are saying our U is equals to 5x and our dv is equals to exponential 4x dx. Now, if U is equals to 5x, then du dx is equals to what? 5. Therefore, dx, or rather du, is equals to 5 dx. Then our v will be integral of exponential 4x dx. And integrating exponential 4x dx will have 1 over 4 exponential 4x, because integrating exponential ax with respect to x will have 1 over a exponential ax. Now we have u to be 5x, we have du to be 5 dx, we have dv to be exponential 4x dx, and we have v to be 1 over 4 exponential 4x. Now let's simplify 5x exponential 4x to be integrated with respect to x. And we call our formula for integration by parts, which is integral of u dv is equals to uv minus integral of v du. Therefore, integral of 5x exponential 4x dx is equals to u, our u is 5x, v, our v is 1 over 4 exponential 4x, minus integral of v, which is 1 over 4 exponential 4x, and our du, which is 5 dx. So we can simplify it further to give 5 over 4 x exponential 4x minus 5, and 1 over 4 is a constant. It can be brought outside to give 5 over 4 integral of exponential 4x dx. And integrating exponential 4x dx, we would have 1 over 4 exponential 4x plus c, because integrating 1 over integrating exponential ax with respect to x will have 1 over a exponential ax plus c. Now this will give us 5 over 4 exponential x exponential 4x minus 5 over 4, or let's say 5 over 16 exponential 4x plus c. Now we can factorize using 5 over 4 exponential 4x, and this will be x minus 1 over 4 plus c. And this will be an expression for 5x exponential 4x dx. Now if the question is taken further that we should evaluate integral of lower limit 0 to upper limit 1 of 5x exponential 4x with respect to x, then we will have to give 5 over 4 exponential 4x from x minus 1 over 4 from upper limit 1 to lower limit 0. So let us substitute our upper limit 1. So it will be 5 over 4 exponential 4 into 1 into 1 minus 1 over 4 minus our lower limit 0, which will be 5 over 4 exponential 4 into 0 into 1 minus into 0 minus 1 over 4. And simplifying this, we will have 15 over 16 exponential 4 minus into minus 5 over 16. And this will give us 51.5 approximately. Let's take another example. Let's evaluate with respect to t integral of 3t exponential 2t. Now we know that this is arithmetic and this is exponential. And we are dealing with the principle LAET, where our u therefore will be 3t and our dv will be exponential 2t with respect to t. So you can pause the video now and try this. Alright. So if u is equals to 3t, then du dt is equals to what? 3. Therefore du is equals to 3 dt. Now if v is equals to exponential 2t dt, then our v will be integral of exponential 2t with respect to t. And this will give us 1 over 2 exponential 2t. Now we recall that we are dealing with u dv to be equals to uv minus integral of v du. Therefore, integral of 3t exponential 2t dt will be equals to our u, which is 3t, our v, which is 1 over 2 exponential 2t, minus integral of v, 1 over 2 exponential 2t, multiplied by du, which is 3 dt. So simplifying this, we have 3 over 2t exponential 2t minus 3 over 2 integral of exponential 2t with respect to t. Therefore, this will give us 3 over 2 t exponential 2t minus 3 over 2, and integrating exponential 2t, we will have exponential 2t divided by 2 plus c. So in conclusion, this will give us 3 over 2 t exponential 2t minus 3 over 4 exponential 2t plus c. Factorizing with 3 over 2 exponential 2t, we would have t minus 1 over 2 plus c. Let's take another example. Now we are asked to integrate x squared sine x with respect to x. X squared is arithmetic function, sine x is trigonometric function. And we are dealing with the principle LAET. So which one comes first? The arithmetic function, which becomes our u, and the trigonometric function, which we tag as our v. Therefore, our u is equals to x squared and our dv is equals to sine x dx. So therefore, our du dx is equals to 2x and our du will be equals to 2x dx. To evaluate our v now, our v will be integral of sine x with respect to x, and integrating sine x will have minus cos x. So let us recall now the formula for integration by parts. That integration by parts says that integral of u dv is equals to uv minus integral of v du. Now integral of u, that's x squared dv, that's x squared sine x dx, which is the question, is equals to u x squared v minus cos x minus integral of v again minus cos x multiplied by du, which is 2x dx. So this becomes minus x squared plus x minus, we multiply minus here to give us plus. That will give us 2x plus x dx. 2 is a constant, it can be brought out. That will be minus x squared plus x plus 2 integral of x plus x dx. Now we notice something, that the integral of x cos x with respect to x is not a standard integral, and this can only be determined by using integration by parts formula again. So let us now integrate x cos x with respect to x. Now we solved this earlier on in our first problem, that integral of x cos x is equal to x sin x plus cos x plus c. So integral of x cos x is equals to x sin x plus cos x. Therefore, we make our substitution, that integral of x squared sin x dx will be x minus x squared cos x plus 2 into this x sin x plus cos x plus c. Now this will be minus x squared cos x plus 2x sin x plus 2 cos x plus c. And this will be our answer. Now we notice something. We started with integration by parts. Okay? And if the algebraic term of the product of the power n, we have n raised to power 2. Okay? Then the integration by parts will be applied n times. So we have x squared, and the integration by parts was applied 2 times. It was applied initially, and it was applied here again. So in our next video, we'll be taking more examples on integration by parts.